My name is Krzysztof Zabłocki, Merwing _ on Twitter. I work for the New York Times. Today I'm going to talk about Sourcery. You might know me from a bit of open source that I'm doing every now and then, and there's quite a few projects. They actually don't fit the slides, so I'm just going to focus on Sourcery. And Paweł asked me to talk about it because, like, I did a lot of talks about Sourcery. It's a tool I wrote, but no one did it here, and I don't really speak in Poland most of the time. Since I have to take time off, I prefer to just go abroad. Sourcery is a meta-programming tool. It's basically a tool that learns what your project contains. It reads your Swift source code, it analyzes it, it builds abstract syntax tree from your types, and then it allows you to feed it to templates. I'm going to talk about what templates are, and it's going to generate more code for you. It doesn't have to be code, it can generate anything, but most of the time it's more Swift code. And so it works like a preprocessor in your build phases. It happens before the actual Swift compilation, so there is no runtime magic, there is no, there's nothing that can actually hide underneath you. Like in Objective-C, you would use runtime to do a lot of interesting tricks, but you wouldn't actually see what it's doing. Whereas this works as preprocessor, so everything is compiled, you get compile time errors, and that is so much better. And so what are templates? Templates is basically the same way as you have with HTML or other web languages, you can render pages. This is what templates do in Sourcery as well. So you have your AST information for each of the template languages. We support 3 different template languages right now, and you can basically just print strings. That is basically what templates mean. And so what are the templating language we have? So Stencil is one of them, Swift, which is our custom one, and then there is effective JavaScript. So this is how basic Stencil template might look like. For enumeration in types.all, which is basically just an array, we can just print the name of the type, and that is how it would look like. The same logic in Swift templates would look like this. So almost no difference, except there are different tags for you. So like here you can see that there is just braces and the percentage sign, and here you have the triangle braces, right? So very simple. AJS looks very similar, except you have the separation here. So the basics are very simple. I'm going to talk about Stencil because Stencil is the simplest language. It's it was based on Swift, but it's much simpler. It's not Turing complete, so you cannot do everything with it. But for most of the boilerplate needs you will ever have to do, it's simple enough. And because it's not a fully blown language, it doesn't require compilation, so it's extremely fast to run. And that is very important. So what are some of the Sourcery features that you care about? So first off, it's powered by Apple's own SourceKit. It's not us trying to understand what Swift means, it's just using the Apple tools. We have our own parsers built on top of it because SourceKit doesn't actually care about everything. So for example, when we scan enumerations, SourceKit will tell us that there is multiple cases in your enum definition, but it won't tell us what are the arguments name for each of the types in your associated values. So we need that information to give you more power. And it can generate general Swift code, it can generate documentation, it can generate whatever the hell you want. It can generate Objective-C. So you can have Swift and you have template written in Stencil, Swift, or AJS, and from that you can actually generate Objective-C. And I know people that actually do that, which is crazy. And because of the preprocessor approach that it uses, all of the code is compiled. So you can even generate warnings and errors that will stop your compilation process. So for example, if your template requires the types to be annotated with specific information, and that information is missing, you can just stop building, which is much better than runtime errors. And it's fully typed because it's just Swift. And what's nice about it and what makes it very easy to write your own templates, not just rely on the built-in ones, is that it comes with a built-in watcher, which means that any code that you type, you can observe in real time. So it's very easy to learn templating languages. So as you can see here, I'm inspecting New York Times code base. Back in 0.6, now we have a 16 release version, so it's very old, but basically this is very useful. You can see that it's not only for code generation, it can also be used for understanding what your types actually do in your project. I even have a template that generates a bash script that attributes final to every class that can be final. And it's like 3 lines of code. So basically there's like a template that uses AST to find all classes that don't have subclasses, and then uses grep and what was the name of the shell command? AWK, and then replaces those definitions with final. So it automatically adds final to everything. So you can do pretty crazy stuff. I don't recommend doing that, but it's doable. One of the nice things that Sourcery brings to Swift is source annotations. So similar how you had it in Java, you can attribute both types and variables with extra information. That means that if you have a variable that you want to skip in your template, you can just write comment Sourcery and then skip persistence, or Sourcery JSON key equals that. And that allows you to tweak your behavior in your templates. So for example, Apple gives you codable now, right? And equality and hashing. All of those are either you take what we give you by default or you write your own. The moment you have to write your own, the moment you have customization, is the moment that you go back to all the problems that you had before, which is maintaining those implementations. Whereas with Sourcery, we have equality and hashing, and we have way more powerful codable extension. So we use codable, but we build all the boilerplate around having custom keys and everything like that in the template. And that basically allows you to, even when you have custom code paths in your types, you don't actually have to maintain that. So whenever you add new variable, it's automatically picked up, it's automatically added. There is never a potential for bugs to be created, which is awesome. It also allows you to inline code generation. So for example, if you have, like the default way that Sourcery works, it will generate the source code in a separate file. That doesn't always work, because if you have things like required initializers, those have to exist in your code definition of the type. It cannot happen in an extension. Swift doesn't allow that. And so this is why inline code generation exists. The same with NS coding, for example. And so it's as simple as specifying Sourcery inline auto in your template, and then if it sees the type, like in the bottom here, class my type, it will automatically add the code that this template generates at the bottom of that definition. So it's really simple to use. And so how do you integrate Sourcery in your project? It's very simple. You just use a build phase. That is the best way you should integrate it. You can run it manually. You can install it using Brew. You can install it using Mint. You can install it using Swift's package manager. This is the way you should integrate it, though, because what that gives you is that gives you confidence that whenever the code changes, whenever the output of your file or your project changes, it will regenerate all the boilerplate. So the boilerplate will always match your types, and because of that, you'll avoid potential human mistakes. And it also comes bundled with a lot of templates. So when you're working on a new template, you definitely want to use the real-time feedback one. I'm going to show you a couple of examples of how that can be used and what templates we have. And a big question that people always have is it going to slow down my builds? And so it has very fast parsing. It's actually multi-threaded. So all the files are scanned in parallel, and then there is concatenation phase when all the results are combined together to build the full AST. It has extensive caching. The caching is file-based, which means we only reread the file when that file changes. That makes it way faster than what Swift compiler has to do, because they have much stronger dependencies between the files. And the cost is very negligible in comparison to your compile times. This is the time it took for the New York Times, which is less than a second. Our compile time is like 5 minutes. So you wouldn't even notice that you added this. So how can you write custom templates using Stencil? There are a couple of basics. Like a lot of people are afraid of writing their own templates, and this is one of the reasons Pavel asked me to talk about Sourcery a bit here. And so we come bundled with a lot of templates. I'm going to mention all of them in a second. But what happened is Sourcery was created 3 or 4 years ago. So we didn't have equality, we didn't have hashing, we didn't have codable in the Swift language. That actually prompted them to actually create that, because I know people at Apple that use Sourcery and still use Sourcery. And so now we have those things, and a lot of people only use Sourcery for those basic ideas. And so a lot of people might have stopped using it. It's still used by over 30,000 applications right now, so quite a lot. But people are afraid to learn how to write their own templates, and every single project, I work as a consultant, so I'm not only working on the New York Times code base. Every single project I have ever seen has a lot of boilerplate. There are parts of your code base when there are repeated patterns that you could generalize, right? So that is extremely common in programming, and especially in Swift, without runtime, without all that magic that existed in Objective-C. And it's really simple to use Stencil. Those are like the basic definitions that we have. So if you do the first expression here, that just prints the variable in your file. So this is just, if you do like type.name, that will just print the name of your type. The second one allows you to create variables, so it allows you to reuse the same logic, so you can have a complex argumentation rather than repeating it. The third one creates a function, which in Stencil is called macro, but this is again to dry out your code and not repeat yourself. And the last one calls the function. And knowing those four things, you can write 95% of templates you'll ever need, which is very, very simple. There's very little learning to do here. And the only other thing you need to know is what are the meta types that Sourcery gives your template to work with. And again, those are four most important ones, which is ability to access types based on whether they are implementing a protocol, whether they are inheriting from a base class, ability to filter the arrays. So basically, if you do the pipe operator, you can pipe together multiple filters. So you can, for example, you can do types implementing protocol name, pipe enums, which means all the types that are enums, pipe all the types that are not annotated with skip persistence, and you can chain those things together. And then you can just iterate over all of them. And that is the basics of it, really. And so let's look at something practical. I wrote an article a while ago about doing protocol composition using about doing dependency injection using protocol composition. So the way this works is, rather than injecting directly all the dependencies that your types require, so for example, injecting the API client, the content coordinator, and the image provider to your view model or your view controller as separate properties, you can just do a type alias, and you can do has API client, has content coordinator, has image provider as a single dependencies variable. For that to work, you have to have all those boilerplate protocols, which is basically a protocol called has whatever the dependency is that exposes a single variable, which is the dependency name. So that is a lot of boilerplate to generate for the project, but it's extremely simple to actually automate. So I want to have, basically let me actually explain first. So I define the auto properties, which is a phantom protocol. It's just a markup for the templates to pick it up, right? So in my template, I'll do types implementing auto properties. And then for each type that implements that, I want to create a has protocol for each of the variables that the type contains. And I want to conform that type to those protocols as well. So that is the logic for the boilerplate generation. And this is basically how you do it. So I iterate over all types that implement the auto properties. And here I basically just I create a mark first, so the sections between types are in the code-generated code are visible, so I can see which type I'm referring to. So in the sample project, I only have this single dependency structure. Then I iterate over all the variables in that specific type. So I go deeper into the AST. And then for each variable, I create a protocol name first as a variable. So because I have to use it twice, I have to use it for both the has protocol and then for actual conformance in the extension. So I just create a local variable, and it just does formatting for the name. So I have has whatever the dependency is name. And then I just do that. I just use that variable. So I just do protocol name, then expose variable that is the name of the property, and then its type, its actual type. So as you can see, as I'm typing and I'm saving the file, Sourcery generates the code, and I can see the templates happening in real time. And then at the end, what I mentioned before is I want to conform my type to that extension. So for each of those has protocols, the type will automatically conform. So the only code that the programmer has to write is declare what dependencies are the main dependencies of your application, and all the boilerplate will be generated by this template from that point on, which is very nice, especially in bigger projects. Like this is a really simple example, but you can imagine how much more code it can generate. Another thing that I recently built for the times is I have this, we basically want to track events in our application, app events. So things like article has loaded, section front sized an item, so did the cell sizing. And for that, I want to use type API. I don't want to have strings in my definitions of tracking. I still have strings for like the URL and stuff because that's basically what I get from the server. But basically what I do is I have this simple enumeration called app event, and it conforms to auto event convertible. And then I just create cases, and the cases use strings as the actual types that they conform, because that's what Firebase performance require. Firebase doesn't support anything else for performance tracking. And so what I do is my template must generate the name of the type that I'm tracking, the event type, and then the parameters, which is a dictionary of string to string definitions. So for article load, I have two associated values here. I have a sender and a URL. So I want to send both of those to the server. Now, what developer writes is they only write the first part, which is just the enum declaration. What's really nice in our project is that I did it so you can nest the enum generations and use them as namespaces. So I can do like begin event, app event, section front, item size, and all of the sub enums, it's basically like recursive. So I can define as many subdomains as I want, and then all the boilerplate is generated for me. So defining the name is really simple. So here I'm using the function just to show you how that works. So I define a new function called generate name. It accepts a type. And there I basically just do this simple definition. I switch over self, and then I go into the cases that the enumeration has. So for each case, in the type that's passed in as the argument to this function, I will just do case pattern, right? So I'll do, if the case matches the name, I'll just return that name as a string. So I get rid of the associated values. I just use the type name, which is very simple. And I also use the type name because that allows me to do the nested domains very easily. So if I have like the section front thing, it will go into a subdomain. And then I just call that. And that automatically generates the name. Generating the parameters is a little more complicated. So I didn't want to do a GIF because it's hard to explain. I'd rather display the whole thing. I'll show you in a second. But it's also very, like it's more code, but it's still, all the code in the templates are usually very simple. So here, this is all it needs for the app event, and then I create another function called generate parameters. And let me just run it through what this does. So for the type that gets passed to this function, for each case in that type, if the case has associated values, I will bind to all the associated values to a single variable called content. Then I will return, and then I will iterate over all the associated values. If there is just one, then I would just return the content since it's a singular value. If there is more than one, then I would use the local name from the associated value, which is what the definition you made in your case. And I will just access that value, right? And then there's like this little thing here, if not for loop last, that basically means I don't do the comma if it's last item. So it's just the string formatting that I get. If it doesn't have associated values, then I just return nil. So there are no arguments to be passed in. And this is a little bit of code. I structure it so it's more readable, but it's so simple. It's literally like two fors and two main ifs statements, and this gets rid of all the boilerplate we would have to generate otherwise. So it's very simple. And Sourcery comes bundled with many more templates. Equality, hashing are the basic ones that we always have. The enum cases and counts as well. It also comes bundled with a basic mock implementation, which allows you to track a few things I'm going to mention in detail in a second. It has very advanced codable extension that gets rid of all the manual subtypes you would have to create if you want to use codable directly. It doesn't do custom codable. It still does codable using Apple APIs, except it deals with all the boilerplate. It also allows you to do property level diffing, which I'm going to show in a second. It also can generate Linux main, which is what Apple uses a lot. People at Apple use that for their work. It can generate decorators. There's a bunch of other templates. But if anyone does TDD, we have to do equality tests in our expectations. And this is how Xcode thinks equality should look like, the result of equality on a composed object. Can anyone tell me what is different, what doesn't match in the test? Because this is ridiculous that this is what Xcode prints. So basically, when you have two objects that are not primitives, not an int or not a single string, Xcode just prints everything for the first object that you compare and the second object that you compare. And it's up to you to read and find what is wrong, even if it's like a single property. This is ridiculous. This doesn't work very well with TDD approach. So with Sourcery template, the property level diffing, this is the same code. This is the same code. It's just using the property level diffing code template. And what it does, it compares in arrays of objects. It finds that at index 0 there is an object that has local name variable that's incorrect because it expected the value to be foo and it's boofoo. So the difference between readability between this and this is ridiculous. It took me, I think, 40 lines of code to write the template for diffing, and this is what Sourcery uses to generate its own. Like Sourcery generates half of its own code base using Sourcery. So this is one of the things it does because it's all fully test driven, and this makes it so much more efficient to work with tests. So this is one of the coolest templates. Our bundled AutoMockable, for each function, it generates a variable called function called. So if a function is called load configuration, there will be a variable called load configuration called, which is a boolean to allows you to check whether the function was actually called in your mock. It will also contain all the received arguments that were passed into the function. It will also contain a closure that you can inject that will get called when the function gets called. So you can do side effects. It also allows you to return custom value from functions that actually have that definition. It also tracks all the invocations, so you can see each call. There's a lot of things we track. So this is the bundled AutoMockable, which is very, it's very simple, but it's good enough for most people testing needs. If you want something more powerful, there's a lot of tools that people are building based on Sourcery. One of them is SwiftMockey, which is also built by Polish guys, which is cool. And it basically uses Sourcery to generate all the boilerplate to create a very nice DSL for testing. So if you use OSI Mockito or the old Objective-C libraries for testing, this is pretty similar. So basically it allows you to do given and verify. And the only thing that they require you to is to add annotation to your types that you want to be mockable. And then it generates a lot of code to have those kind of APIs, which are really nice. I don't actually use this because I think the simple AutoMockable is enough. But for people that like this kind of DSL, which is very nice looking, this is really cool. Another tool that's built, this is actually a commercial tool that's built on top of Sourcery, which is called ObjectBox, and it's way faster than Realm is for the persistence implementation. They have they basically have multi-platform support, and on iOS they use Sourcery as their base. And what the developer has to do is they just define a class as just conform to entity and then just provide the types. And they generate all the boilerplate that allows you to do a very nice query language. And at the bottom, I don't know how visible that is, but basically you can do person.box query and then person.firstname.starts with whatever. This is a static variable that you don't define, right? So they generate all that code for you. This is really cool. This is actually really cool. It's if you see the performance measurements between that and Realm and other libraries, you'll see why I like it. But there is a lot of things you can build with Sourcery. And Sourcery is open source. It has 73 contributors. It had 52 releases already. It's all free. It's MIT, so you can do whatever the hell you want with it. It can eliminate boilerplate. You can basically the biggest idea here is you can write this template once for all the corner cases you want to deal with, test that it works for those specific scenarios, and then be done with it. I have templates that I wrote 4 years ago and I have not touched since, other than just updating the name so when like the API for the templates changed. But it doesn't really change that often, so very simple. And the biggest benefit is, everyone can write equality. Even before Apple did it with the derived implementation, everyone can write those things. Those things are very simple to do. Like, they're all very trivial and very straightforward. The problem isn't writing them. The problem is there's a lot of boilerplate like that. And when you modify the code that's basically the boilerplate works on, so for example with custom equality implementations, if you remove a variable, the compiler will tell you that you forgot to remove the variable from the boilerplate that you had, because it will just not recognize the symbol. If you add a variable, it will tell you nothing. So if you forget to update any of your boilerplate code, it will create bugs. And this is very common. Like, we had a custom caching for the times. And when someone added some new property to an article and didn't update the boilerplate, what happened is we had the height mismatches in the application, so the things would be cut off. And those are the things that usually come up only in production, and you never want to have that. And I probably touched like 30 or 40 projects in the last 4 years, and every single one of them, there was a lot of boilerplate. So I'm pretty sure that any decent size iOS project has a lot of space for things that you don't have to write. So why bother writing it? The nice thing about Sourcery is that this is the way it works, the way you set it up. It's not a hard dependency. It's not like Eric Swift, when you decide, oh, I'm going to use Eric Swift, and now your whole code base relies on it. And now getting rid of dependency like that is very problematic. So if at some point you decide Eric Swift doesn't work for you, you are in the world of pain, since you have to touch everything in your code base, right? Sourcery is very different because, first off, it works as preprocessor, so you can disable it and your project should still compile. Second of all, it generates the code you want it to generate. It's not opinionated. It doesn't do whatever it wants. It just does what you tell it to do, which means that even if it stops working today, I can take all the generated code that I had from it and just go back to maintaining it by hand. There's no cost for me, right? I would be maintaining it by hand otherwise. So this only, like, as long as it works, it saves me time. If it ever stops working, well, whatever, I would have to maintain it anyway. I just saved 2 or 3 years when it worked, right? So there is really no big problem with that, which is awesome. And if you don't trust me, a lot of people like Sourcery. So I'm going to end on that, and I'm very happy to answer any questions regarding Sourcery or any other open source I do. Does anyone have questions? Or
I wonder if you can use it, for example, if I want to add logs to Fabric or Firebase, and I would like to automatically add logs to each function. So then I can track my error with extra information.
So the way you would, so for example,
so it would parse the code?
Yeah, it doesn't, so it parses types. It doesn't parse the function execution, like it doesn't parse the way your functions work, it parses how they look.
It would be the only way to create the template with already log.
Yeah, so the way I do it, like with the app event tracking, is basically I build a very simple API for our developers that they don't have to deal with all the, all the messy stuff, and they just use typed API, basically just declare enums. And then I use Sourcery to generate all the stringy-based API for the external services. So you could, for each of your types, you could actually generate things that automatically track stuff. So for example, for each type, because it doesn't have to be like types implementing, you could literally run the template on every type in your project. And for every type in your project, for every function in your type, you could add a helper function that automatically tracks all the arguments, right? So, there are ways to do it. I generally tend to do like, okay, I'm gonna do this nice type-based API, and I'm gonna move all the messy stuff to be code-generated. So it doesn't know. I don't want it to know about like the code execution, because that gets very complicated, and that goes back into problems that Swift compiler has with scanning and performance, and we don't want a tool that takes like minutes to parse. Yeah.
No, I thought that if it generates like the files with classes, yes, from types, you could prepare some functions, and it would automatically take that function.
I mean, it can inline. Like if you use the inline annotations, you could inject stuff into your functions. I don't think that's gonna look nice, because it can automatically add new functions to your types, but it will not mutate your function unless you put the markers there. So you could do that, but then you have to add markers to your function calls, basically. So if you had a lot of boilerplate that you need to do, that might make sense, because the marker is basically just a line. That's really like based on whatever the specific use case is. It's doable, but yeah, might not be the ideal thing. Any other questions? If not, then yeah.
I have a question. Do you recommend checking in the generated files to the source code?
Yes, absolutely.
Why?
Do you check in CocoaPods?
Like the dependencies themselves?
Yeah.
Depends on the project.
Okay. So, what is the point of version control, right? CVS. What is the point of that? The point of that is I can go like years later, check out my project and build it, right? That is the point. Now, Swift kind of breaks that promise, because you cannot actually build Swift 2.0 without having the old Xcode, so it's all a mess. But in general, I have a very strong opinion on people, like I strongly disagree with people not making that work. Like even things like, so let's give you an example that happens so often. People have private CocoaPods, right? And when you get hired as a contractor to work on a project, what often happens, people give you access to the main project and they forget to give you access to the private CocoaPods. You cannot build the project. You have to wait for them to give you access to all those different repos, and so you waste time, right? The other thing is, what if there is a new version of system or Xcode or Swift, and one of the tools that you use for your build phases stops working?
Or disappears, basically.
Or disappears, which can happen, right? Obviously, people say, well, CocoaPods is too big. There are still situations when it breaks for any given system version. And the same with, Sourcery actually only breaks for like the Swift templates, mostly because of the language being unstable. But that can happen, right? You have to have the ability to run your code if that happens, right? So maybe you won't be able to add a new pod when CocoaPods break, but you'll still be able to work on the project, right? And so for me, and Orta agrees with me on that, both CocoaPods and generated code should be in your repository.
So basically what's in the master branch should always build in its form?
Yeah, it should always build, yeah. If it doesn't, then like I've been programming for 23 years now, and so I have projects that the dependencies no longer exist. I cannot build, even though they're really cool, because like 3D game engines I built in high school, I cannot build them anymore. I actually got one to build. It took me a month to get it to work. So that is not, that isn't how version control should work. So yeah, that is very strong opinion. There's no benefit, right? The people. So there are only one situation that I can accept. Sometimes you have frameworks like Google likes to do this massive file that's over 100 megs, and GitHub doesn't accept that. You cannot have a single file, and that is very, very bad. But that is the only argument I could accept. Like people saying like, well, the repo is gonna weigh too much. I'm like, buy a faster network.
Yeah, sometimes people also complain that there is too much code in the pull request, but actually you can use like Git attributes for that, so GitHub collapses the generated code.
Yeah, well, that's the thing, right? So Atlassian, their what was the Stash was it the name, the self-hosted Bitbucket version? They basically they have ability, like you have the cloud version, which is the basically Bitbucket, and then you have the self-hosted version, which worked for pull requests much better than GitHub still does. On the left, you had the list of files in folders, and you could just go file by file. You could just skip pods altogether.
Yeah.
That's so much nicer. Sorry?
I think GitHub has that as well, like filtering by. Oh,
no, GitHub breaks every time I do a massive refactor. Like I have a refactor that touches 800 files. I cannot even open that PR. Yeah. So GitHub is still a lot of things they have to fix. At least they're doing some progress now that Microsoft bought them. Yeah. All right. Any other questions?
I have a second question. My second question is, what frustrated you that much that you actually decided to write this tool?
All the tools I write. Like I often say that what I do is I do pain-driven development, and you know, this is the thing. Like I work on different projects. I get hired as a consultant. One of the most common things I do get hired for is doing a code review for the whole project, and then giving a recommendation of what could be improved, what could be automated, blah blah blah. And every single project has the base problems are always the same, and no one fixes it. Or like how many times do you write equality? How many times do you deal, like writing equality is fine, right? How many times do you encounter the problems with people not updating the boilerplate before you get pissed off? Like, I mean, I'm a professional and I get paid to solve problems, and like, this is not productive. This is not productive for anyone to write. If this is something that you can, basically, if an algorithm is something I can describe to you, and you don't even have to take notes, why would you not automate that? That makes no sense. Like a lot of the tools I have, like for example, I don't know, is anyone familiar with Lifetime Tracker? So this is such a simple tool. Basically what it does is it tracks the instances of your classes that are alive. It's literally a freaking counter. That's what it is. That is the whole tool, except it has some UI that automatically pops up. How does that work? So you conform to Lifetime Trackable. You define, okay, this type should only ever exist in 2 instances in my project, which, you know, a lot of times you can tell about a different type. For us, like for the times, we only cache 3 section fronts. When you swipe sideways, you can have up to 3. So whenever there is more than 3, it means we have retain cycle. It's as simple as that. And for a lot of types in the project, you'll usually have only 1 in healthy condition. Obviously, there are situations where you can get to multiple ones, but this is basically defining what is the default count that's allowed for normal execution. And so how it works, right? You define that. At the end of your initializer, you just call track lifetime, and it automatically registers like a callback that gets called when the object gets deallocated using the associated object trick. And what happens? It just increments or decrements a counter for that type. When the counter goes over the limit that you said the limit is, you get a pop-up with UI that says that there is a retain cycle. And this is something I created because I was asked to fix retain cycles month after month. And you know, I would fix retain cycles in our app. We have a lot of closures. And then a month later, people would already have to introduce more, right? And Apple gives you the memory graph debugger, and they give you the leaks instruments. No one uses that. The problem with tooling that is not automated is that you have to take conscious effort to actually use it. And what happens most of the time, people get under pressure or they forget. And the biggest issue is, even if you use it at some point, the amount of diff that happened from the last time you used it, it's enormous. And as easy as it is to find delegates that are strong, because that shows up in the memory graph debugger very clearly, closures do not. So with closures, it's still like you have to comment out a bunch of code and then see, does it still happen? Then you have to comment out and build and build and build. And so by the time you actually realize that there are problems, which often happens because the app starts crashing because of memory in production, usually. And so by the time that happens, you have to bisect the whole tree. And that can take a while. That for us would take days to find the problems. And so I built this tool, and it keeps finding errors as people develop, right? So we recently found that we are leaking ads, and that's the most expensive thing we have in the project. And we actually found that not working on ads. We just someone was just navigating through the app, and the counter of ads didn't decrement, and so we found retain cycle, and then we could fix it before the next release came out. And so a lot of those tools are basically just seeing the problems, and the biggest thing for me is if it happens once, that's fine. If it happens twice, okay, it's on my radar. But I'm not gonna fix it yet, right? But if I see it happens 3 times or more, that means it doesn't just happen for me. It happens for probably everyone on the team. And so I try to find a way to fix the problem on a bigger scale. I actually wrote Sourcery much sooner. I wrote it a couple years ago before the official release. And I did it for a client. And basically I told them this is very simple. I like the idea I made here, and I'll give you a year to open source it. If you don't open source it, I'm gonna write it properly. And so they didn't open source it, so I open sourced it. So I wrote it in Swift 2.0 or something. So yeah, so that works very well. Sourcery, it's by far the most popular tool I wrote. It's used by over 30,000 apps. I don't know exact numbers because the tracking broke on CocoaPods and everything. But yeah. The lifetime tracker it's ridiculous how simple it is. It's literally the logic behind it is 20 lines of code or so. So yeah, that's pretty much it. Pain-driven development, that's the key.
Automated work, best work.
So we even automate, so the track lifetime you have to call at the end of your initializer. So I automated that using Danger. So whenever you make a PR and you forget to call track lifetime, but you say that your object is lifetime trackable, the Danger won't allow you to merge the PR. So even if you cannot automate something at the level of the build time on your project, you can automate it at the review time. Yeah, so automate everything you can. There's literally, there is no proper argumentation for doing things manually that the machine can do. I had people tell me that, oh, we are good developers, we won't do it, we don't need to automate. I'm like, I don't trust you, I don't trust myself to do it. That's ridiculous. We can write a grep script that finds this problem. Why would we not? This makes no sense to me. Yeah. But I've been doing this for a while, so I'm very lazy. So, hey, thank you.